Hello everyone. Today we'll be doing adders. So let us start. What is adders? In simplest term, you can say it's a combination of logic gates to perform binary addition. And the adder has, I think so there are two types of adders. One is a half adder, and the other one is a full adder. Right. So let us start with half adder. Half adder here, you just need to remember the summing rules from the numbering systems. So where we had two inputs A and B, 0, 0, 0, 1, 1, 0, and 1, 1. And when we add them together, we had two outputs, a sum and a carry. So we had a carry and a sum. So just remember carry is our MSB. So in this case 0 plus 0, our carry 0 sum is 0. Right. Then 0 plus 1, our carry is 0, sum is 1. 1 plus 0, carry is 0, sum is 1. 1 plus 1, our carry is 1 and sum is 0, right? Then our logic circuit for the half adder comes from these two outputs, our carry and our sum, right? And then it's and what you see when you see carry, our carry is representing a logic gate. If you remember truth table for a AND gate, so that is what our carry is representing, right? And our sum is representing exclusive OR gate. If you look at the truth table, that will show you the output for exclusive OR gate. So our half adder is a combination of these two logic gates, right? So let's just draw them. We have our input A and B. Then you will have our input lines. Then our exclusive OR gate that will represent our sum. Then we have our input A and B. And then we have our AND gate, which is our carry, right? And then our equation will be Boolean equation will be for the exclusive OR gate and the AND gate, right? So this is our logic gate representation of a half adder. And it can also be represented like this, or the most common way to represent a half adder. We have a block, two inputs, then some output, and then we have C out, we call it carry out. And here we will have our exclusive OR gates equation, and then the two inputs, and then our carry out will be AND gate. So you can, this is our half adder. Right. So this is our half adder now. But then if you think about it, our half adder is missing something. We need as another input, right? Where you need another input that can take a carry in. So that will show you in a full adder. So let's go to the full adder now. So our full adder has now three inputs. We have A, we have B, and C. So we can write 0, 0, 0, 0, 0, 1, 1, 0, and then 0, 1, 1, 1, 0, 0, 1, 0, 1. Up until I think so it's 3 bits, so it will be up until 1, 1, 0 and 1, 1, 1. Right, then again we'll have our carry, we call it out, then our sum, right? And if you add now these three numbers, in this case 0, 0, our carry is 0, our sum is 0. And if you add 0 plus 1, our carry is 0, sum is 1. And if you say 0 plus 1 plus 0, still our carry is 0, sum is 1. Then 0 plus 1 plus 1, carry 1, sum is 0, right? Then we go on 1 plus 0, carry 0, sum is 1. Then 1 plus 0 plus 1, uh, carry 1, sum is 0. We do the same, carry 1, sum 0. Then 1 plus 1 plus 1. We'll have 1 and sum, carry 1, sum is 1, right? So this is our truth table for the full adder. And you can perform um, you can use Kono maps to get the output equation for carry out and the sum. Using Kono maps, it can work out. And your output would be something like this. So our carry out equation will be something like this: A plus V, our exclusive OR get, then another exclusive OR C. No, sorry. And that will be our sum. So our sum for the full adder will be, the equation for the full adder will be then C, right? And then the equation for carry out will be A times B plus A plus B, the exclusive OR expression times C, right? And just remember this C we represent most of the time, you will see we call it carry in. So that will represent something like C in. So we can write in here, C in here. And as you can see, it's a combination of two half adders. So let's see how this circuit diagram looks like. So our full adder circuit diagram will be something like this. So we have our input A and B. This is just using half adders. Then our sum, and then our, we can say sum and our carry out, right? Then we have our second half adder, where we have A, B, then our sum, and again our carry out. So our input A goes there and B goes there, right? And then we have our input C. So Then our sum from the first one goes to the input A. Then our C goes to input B. Then we have our two carry outs, as you can see. These two carry outs, right? And then that will be added with our, then we have our OR gate here. So that will be our sum, this will be our carry out, and then our equation for that sum. So this is our uh, a full adder representation using half adders. And then the full adder representation will look something like this. So you will have your carry in B and A, three inputs, then you will have your sum output and then your carry out. So this is your full adder, right? So this will be your inputs. As I said, carry in, carry out, and then our sum. So this is our full adder, and you can say it's a 1 bit full adder. So it can perform 1 bit additions or 3 bit if you have your um, scene. Yeah. So this is our full adder representation. So this is your full adder and half adder. Let's look at some examples where sometimes they ask you to do to perform parallel adders, right? But we'll come there. And there's another, I think so, in your with IC you will have a 4-bit adder, 4-bit full adder that you get in your component list. We call that, if you go down, yeah, so we call that 74LS 283. So you call it 74LS 283. So you'll have 4 input. So A0, you can say A1, A2, and A3. Then again here you will have B1, B01, B2, and B3. Then you have your carry in. Then your output will be sum 0, sum 1, sum 2, sum 3, and then your carry out. Alright, so this is your 4-bit full adder. Now we go to something we call parallel adders. So parallel adders just is parallel adders, or you can say cascading adders. So cascading adder means you're combining 4-bit, you're combining the full adders, or you're adding multiple full adders together, or yeah, you're adding multiple full adders together. So let's do an example. Let's say, for example, if you want to add 1 plus 0, 101 plus 100, right? using full adder. So how are we going to do it? So this will be our first you can do assign the values a0 and a3, right? Then I'll b0, b1 and b2. Sorry, 2. Let me just erase that, and should be 2. Okay, so this will be a2. So we have our values, and then let's say we use uh, so in this case we'll use 3 full adders to do our diagram, right? So you will have, and we most of the time we start from the um, right or left, yeah, from the left or right. So you start with the LSB. Let's just say that, yeah. So you have your adder, and yeah, we can just draw it like this. You will have your inputs, so B0 and A0, right? And then you have your, you can draw your carry in here. Then we have our sum out, so we can call that sum 0, A, B, and then C out here, right? And in this case, we don't have any carry. If you remember, we are not adding any other value, right? So you can say our carry, it's that third bit, which is just 0, right? So you can say this is carry in, and when it's 0, so we can connect it to ground, right? And then we get our output to be sum 0. So that's our first adder, then we'll have our second one. So this will be what? 0 plus 1. Alright. And if you remember 0 plus 1, our sum is 1, carry is 0. So this carry will be 0. Again, we'll have our carry in that will connect to carry out here. Then our input will be A1 and B1. A and B. Alright. And then we'll have our again sum 1 and C out. Right. So we'll call that sum 1. Then again our last third adder. Sorry, the diagram looks a bit skew. We have our scene again that goes to our carry out. Then we'll have our A2, B2, then our sum 2, C out. Right, and you can call this, sorry, then you can call this sum 3. So this will be your MSB output, and this will be your LSB output. Right. So this is what they just call parallel adders, where you're cascading or you're just adding multiple 1-bit adders together. So this will be a 3-bit or 3 full adders, or you can say, yeah, you can just say it's a 3-bit full adder. Then other questions, you can have 4 of them or 5 or 6, but then you follow the same method, right? So that's your adder. And sometimes the same question can be asked something like this. Also, you can add 0, then that will be also 0, 0, and 1, 1. Then if you add these two together, our output will be 1, 0, 1, 0, right? So it will be 0, 0, 0, 1. So that's our output, and sometimes it can be, let's say again, you have the same values, 1, 0, 1 plus 1, 0, 0, and then they use oh, 1 half adder and 2 full adders, right? So how will you do that? And still the same. So you will just replace the first one with a half adder. That means you don't have a carry in, right? And just remember B0, B1, B2, A0, A1, and A2. So you will have your B0, yes, A1, oh sorry, A0. Then you will just have your sum 0 and then your carry out. Then here you will have two full adders that has a carry in, right? So you will have B1, A1. Then you will have your sum one, right? And then your carry out. Then you will have your other C in, then goes there. And then you will have your A2, B2, A and B, then your C out, and then your sum 2, and this will be your last sum 3. And then that's it. So it can also be like this. Using one half adders, and so yeah, this is how it will be using one half adder and two full adders. Okay. Uh, yeah, and then there could also be like a question. Let's just say this is another form of parallel adders. You can say another one can be, let's say you want to add two 8-bit numbers using 4-bit adders, which is also simple. So you will have a adder, a 4-bit adder here, right? And then you will have your input from A0 to A4, and then you will have your input from B0 to B3, sorry, A3, and that will be A3. Right, so your input from A0 to A3, and then your input from B0 to B3, and then your carry in, which we said will be just zeros, right? So it's a ground. And then you will have your sum out as from sum 0 to sum 3, then your carry out. That will go into the second 4-bit adder, right? So it will go there, your carry in, and then here you will have A4 to A7. The numbers, your input, again A4 to A7, then the same, you'll have from B4 to B7, your input, B4 to B7, and then your output will be the sum that will be from sum 4 to sum 7, right? And then you will have your carry out, which we can say is sum 8. And just remember these lines, they're just representing 4-bit input. It's a faster way to draw it. So it's just the same thing from if you write A0, A1, A2, A3, and 4 lines, just to save time. But then, yeah, it just represents 4-bit input. So this is how you can use two, uh, add two numbers using uh, two 8-bit numbers using 4-bit adders. So you will have two 4-bit adders. Sometimes they don't give you the value, so you will have to see you need two 4-bit adders. Yeah. Okay. Uh, so this was your adder. Yeah, this was the adders. Thank you.